So what I want to do is I want to do two things. First, I want to briefly review the 3 advanced derivative rules that we went over yesterday. And then I want to, there are 36 problems on the worksheet I gave you. I want to do as many of them as we can with the purpose of, so that you can see if you got them right, and also so people who are watching the video can check their work on this worksheet. Now let me remind you folks, and I'm making you a promise. If you don't do these derivatives, you will not know these derivative rules. It's a guarantee. Every student I've ever had that practiced them knew them. Everyone who didn't practice them didn't know them. I had students in April of the school year who could not do the product rule. They would stare at it and they'd say, oh, what's the product rule again? 6 months after they learned it, 7 months after they learned it. What's the power rule again, or what's the product rule again? Folks, I don't mind if you say what's the product rule again at the end of October, but if by December when you take the final exam you don't know the product rule, you're in trouble, okay? I'm not saying you're in trouble like your life is going to end. I just mean you're in trouble. That is an indicator that you are not doing what you're supposed to do to understand calculus, okay? So the best way to learn these things is to do them. So we learned 3 rules yesterday. We learned what is called the product rule. We learned the quotient rule. And we learned the chain rule. The product rule for derivatives is used when your function, let's say we have f of x, is equal to x squared times sine of x. It is a function that is 2 separate functions multiplied by each other. A function times a function. And if you want to identify the derivative, f prime, the derivative is going to be the derivative of the first function, 2x, times the second function, not times the derivative of the second function. It's the derivative of the first times the second, okay? So if we call this u times v, okay, then the derivative would be u prime times v plus the first function, not its derivative, times the derivative of the second function, cosine of x. So it would be plus u times v prime.
That's the whole thing?
That's the whole product rule. The derivative of the first times the second plus the first times the derivative of the second. That's it. That's the product rule. So every single time you do a product, the derivative of a product of 2 functions, this is a product. Oh, derivative of the first times the second plus the first times the derivative of the second, you're good to go. I mean, technically, because it's addition, you could swap it around and do it the other way. I like to memorize it one way and do it that way every time. Okay? All right, now let's say that you have some function. We'll call it g of x. And let's say that this function is a quotient of 2 functions. We're going to say that it is x squared divided by sine of x. So we have a function divided by another function. And so the derivative, g prime, is going to be, here's how it goes. It's going to be a fraction, okay? Kind of a big fraction. It's going to be the derivative of the top, which is 2x, times the bottom. Okay, so it's top prime times bottom. All right, so on that first part, the bottom is not the derivative. Minus, because minus is usually associated with division, right? Minus the top, x squared, times the derivative of the bottom, cosine of x. So minus top times bottom prime. Okay, so you do the derivative of the top one time and you do the derivative of the bottom one time. Okay, and it has to be in this order because it's subtraction. So you always start with the derivative of the top. Always. Well, wait, we're almost done. Over the bottom square. I'll write this here. The bottom function squared. And in this case, our bottom sine of x squared. Yeah, but if you're going to write it as sine of x squared, make sure you put it in parentheses and then put a square. You could also write this as sine squared of x, right? Because sine of x squared is the same thing as sine squared of x. Are we good so far? That is the second rule that we learned. So we learned the product rule and the quotient rule. Last one is the chain rule. The chain rule is for functions that are called composition functions. And a composition function looks something like this. Let's use y, the notation y this time. Let's say that y is equal to sine of x squared. Sine of x squared. This, you're going to use the chain rule when you have a function inside of another function. I have heard somebody, a couple people here and there, refer to this as, you ready for this? A pregnant function. Yeah. A pregnant function. It's a function that has a function inside of it. Does that make sense? So I don't know if that helps you or not. But some people refer to it as a pregnant function. So you have the inside function, the baby, right? And then the outside function, the mommy, right? Okay? All right. You will know that you need the chain rule. Here's how you'll know. Does anybody remember what I said yesterday about how you'll know when you need?
Well, there's a compound function inside of it.
Right, but what did I say? What's a surefire way of noticing it?
Where x should be, there's more than just an x.
Correct. Where you would normally see just an x, there's something other than just x. Okay? So normally, wouldn't we normally just see sine of x? Yeah. But instead of seeing sine of x, we are seeing sine of x squared. That's not just x. Therefore, we need the chain rule. Another example would be if this said sine of 3x. Some people think, well, 3x, that's not that big of a deal, right? I mean, it's still basically x with just a 3 on it. Right, that's the problem. It has a 3 on it. It's not just x. So you would use the chain rule. All right, the chain rule goes like this. You're going to do, so to identify the derivative, dy dx, okay, you're going to do, now I'm going to tell you the way I do it. Technically, you could do it in a couple different orders, but I'm going to tell you how I do it, okay? The derivative of the inside. What is the inside function? X squared. And what's the derivative of x squared? 2x. So it's the derivative of the inside, 2x. So I'm going to write inside prime. Oops. Inside prime times the derivative of the outside function, the derivative of the mommy. Okay, what's the derivative of sine? Cosine. Cosine. But now when you write cosine, when you write the derivative of the outside, you have to leave the inside unchanged. We've got to leave it as x squared. So it's the derivative of the inside times the derivative of the outside. So outside prime of inside. Inside, not derivative. Okay? We good? Those are the three, I'm probably the only one that calls it these. These are what I call the advanced derivative rules. Your basic rules, your power rule, your exponential rule, your logarithm rule, your trig rules, those are all what I call the basic derivative rules. These are what I call the advanced derivative rules because they are. No, do you notice how when we do these, when we do the product rule, quotient rule, and chain rule, what are we applying to the individual derivatives? What rules are we applying to the individual derivatives? The basic rules. Yeah, when we do, the square or the derivative of x squared, we're applying the power rule. Then we're applying the derivative of a trig, right? Okay? We use the basic rules to accomplish the advanced derivative rules. Yes.
This can only be used for trig and...
Well, yeah, but here's the thing is, if this said the natural log of x squared, we could still do the derivative of the inside 2x times the derivative of the natural log, which is 1 over x, but instead of making it 1 over x, it'd be 1 over x squared. Where we would have an x, we would put in an x squared. Okay? All right, so you guys ready to do all those, or a bunch of those problems? Yeah. Okay, let's do it. Okay. And if you need a refresher on these rules, guess what you can do? Go to YouTube and find it. Yep. Today is day 26. Today is day 26. So it'll say day 26. Okay, so let's see here. Let's look at this. So we got this piece of paper, right? Okay, and the very first one says, question number one. Question number one says, y is equal to 4x squared times e to the x. Which rule do we need? The product rule. So y prime, the derivative, is going to be the derivative of the first function, 8x, times the second function, plus the first function, 4x squared, times the derivative of the second function, and which is e to the x, right? E to the x. There we go. So our derivative is going to be 8x times e to the x plus 4x squared times e to the x, which you could manipulate algebraically. No, we're done. Yeah, we're done. We're done. Okay. You could manipulate this algebraically. You could factor out an e to the x if you wanted to. You could factor out a 4. You could factor out an x. Okay? So if you want, no, you don't have to. But what I'm saying is this, is that there are times in a math class, maybe like a higher level math class, like Calc 2 or Calc 3, where factoring something out to solve some other kind of problem may be necessary. Okay? But that's all I want you to know right now. All right, let's look at question number 2. Question number 2 is, we got f of x is equal to 7x cubed times sine of x. Well, this is just like one that we just did anyway, right? In the when I was telling you the rule. So f prime of x is going to be derivative of the first. By the way, you can ask questions if you want. I'm just going to plow through all 36 of these problems. If you want to ask questions, that's fine. I recommend that you try to be 1 or 2 steps ahead of me. I recommend that you try to predict what I'm about to write on the board. And if you're watching the video, you can pause it and work it out. Predict what I'm about to put on the board. And if I don't put on the board what you thought I was going to put on the board, what might you want to do? Ask me a question. That's right. Okay. So I'm going to do the derivative of the first one, which is 21x squared, times the second one, plus the first one, 7x cubed, times the derivative of the second one, cosine of x, and there's our derivative. Okay? And I'm telling you, after you do a whole mess of these, you don't even think about it. I don't think about it. I just do it. My brain's just... All right. Do you know why I throw these in here, these v of t's? Because we are eventually, after you know your derivatives well enough, we're going to learn about physics in here. We're going to learn about particle object motion, particle motion. Okay? It's going to be good. And one of the things that you have to know how to do, you have to learn how to identify or how to work with the velocity of a function. That's what v of t stands for. The velocity. Yep. So the velocity here is going to be the natural log of t times cosine of t. Again, we got 2 functions here, right? Now, so v prime of t, does anybody know what v prime of t is? I'm just curious. Does anybody know what v prime of t is?
Like what it is?
It is something. It is actually something in physics, but I don't want to tell you what it is unless you know. You already know, don't you?
It's velocity.
Yes, it's velocity over time, but what is the rate of change in velocity? Acceleration. That's right. So v prime of t, the derivative of velocity, is actually acceleration, a of t. Okay? So it's a product here, so we're going to do the derivative of the first, which is 1 over t, times the second, cosine of t, plus the first, natural log of t, times, now the derivative of cosine is negative sine, right?
Yeah.
But I don't like the way this looks. This looks clunky. Okay? It looks a little clunky, so I'm going to clean it up a little bit. Watch what I'm going to do. First, I'm going to clean this up. You know what this can become?
Cosine t over t.
Cosine of t over t. So we've got cosine of t over t. And then this is positive natural log times negative sine. And what's a positive times a negative?
Minus.
A negative. So I'm going to put a minus sign. And then we'll put natural log of t times sine of t. There we go. There's our derivative. Okay. I'm going to erase 1 and 2. All right. Let's do number 4 now. Question number 4 says g of x. G of x is 3x squared natural log of x. This one's a fun one. I like this one. Yep. Austin knows why. Okay. Yeah, because stuff's going to cancel. Yep, I like it. Yep. All right, so derivative of the first is 6x times the second natural log of x plus the first 3x squared times the derivative of natural log of x is 1 over x. And so now g prime is going to be, we're going to leave the 6x times the natural log of x. Now here, 3x squared times 1 over x, this piece right here is the same thing as 3x squared over x. So what's that going to become? Just 3x, right? We're going to cancel an x in the top and the bottom, right? Listen, here's what I'm warning you. I think you should know how to do it. If you write this on the quiz that I'm going to give you next week, I'm great, fine. I'm good with that. I'll take it, right? However, what I'm telling you is that on the AP exam, they are not going to put this as the product of this. If this is an actual problem on the AP exam, okay, first of all, they may write it like this, possible. They may even factor out the 3x, because you can take a 3x out of here and a 3x out of here. Okay? Well, that's debatable. Let me tell you why they might not. Okay. Let me tell you why they're going to simplify this and they may not simplify this. They're going to simplify this because I think there are a lot of math people in this world that just cannot stand to see that. It must be simplified. However, the reason they may not factor out here is because they're going to say, well, we're not testing people on how to factor, we're testing them on how to do calculus. See what I mean? Yeah, but the thing is this, man, they just can't leave it. They just can't leave it alone. Yeah. See, this isn't factoring, you know? And the truth is that there are a lot of people that they don't have the eye for detail for factoring, but they do have the ability to do calculus. And on the AP exam, they're trying to separate mathematical skills. They are trying to focus on testing people on calculus, not on factoring. Okay? All right, let's do number 5 now. So number 5 is a of t, that's acceleration, by the way. You know what the derivative of acceleration is called?
Wait.
Acceleration. Something.
It's called jerk. It's called jerk. Like when you're on a roller coaster and you get jerked while you're... Jerk is a very... I know, it sounds funny. It's also called jolt in the UK. Jolt. Yeah. So when you get jolted around, that's very important because if you get jolted too much, guess what could happen to you?
Brain injury.
Yeah, you could have a lot of physical injuries. And so they don't want that to happen at an amusement park where people are paying a lot of money to go have fun. If you're paying a lot of money to go have fun, they don't want you to walk out with physical problems.
And lawsuits.
You know, and lawsuits, yes, correct. All right, so a of t here is e to the t power times tangent of t. All right, so the derivative a prime of t, you can just leave it as a prime of t. You don't have to call it jolt or jerk or anything. All right, derivative of the first term is e to the t times the second term, tangent of t, plus the first term, e to the t, times the derivative of the second term, which in this case is secant squared of t. There we go. Good to go. Okay. I'm going to erase number 3 here. Now we're going to do number 6. Question number 6. Okay. All right, question number 6 says h of x is 4x times cotangent of x. So h of x equals 4x times cotangent of x. Whoops. I think it's 4x cotangent of x. Yeah, okay, good. Oh, you're saying that it should start with 4. I agree with you. Because the derivative of 4x, derivative of the first, 4x, is 4 times cotangent of x plus 4x times, what's the derivative of cotangent?
Negative secant.
Negative cosecant squared, right? Now, I want to clean this up because I got a positive times a negative, right? So I'm going to make it h prime of x is equal to 4 cotangent of x. Positive times a negative is a negative. And then 4x cosecant squared of x. And could you maybe try to convert this like it's a trigonometric identity? Sure, why not if you want to, but they're probably not going to make you do it. Okay? because they're not testing you on whether you know trig identities. They're testing you. I mean, not that you don't have to know trig identities. Did you know that trigonometry, trigonometric identities, the knowledge of trigonometric identities, is a mandatory prerequisite for AP Calculus?
What?
You have to know how, you have to have taken a class that teaches you trigonometric identities. I understand that not all of you remember them, but trigonometric identities are kind of fun. All right, that's the product rule. Let's go on to the quotient rule. Quotient rule. All right, question number 7 says f of x is equal to, what's the bottom? Over sine of x. Okay, so we got 6x squared over sine of x. This is very similar to the example that we did. If you don't mind, because it's I'll do it vertically. All right, so f prime of x here is going to be the derivative of the top, derivative of the top, which is 12x, times the bottom, sine of x, minus the top, 6x squared, times, and what's the derivative of sine of x? Cosine of x, all over sine squared of x, the bottom squared. There we go, derivative done, moving on.
So I need to.
Yep, yes?
Could you also put parentheses sine x to the second?
Yes, that would be fine. Can somebody grab that? I think they're probably just looking for somebody from the classroom. All right, question number 8. Let's see here. V of t, velocity. Okay, so number 8, v of t velocity is going to be e to the t over cosine of t. So the derivative is going to be derivative of the top, e to the t, times the bottom, minus the top, e to the t, times what? The derivative of the bottom, which is negative sine of t. Yes, we're getting there. We're getting there, yes. He's asking, wouldn't this become addition? And yes, here's what I want to do. I want to go ahead and do the whole derivative for the people who don't get that yet, and then we'll make the change. Okay? So top times the derivative of the bottom over the bottom squared, cosine squared of t, right? Now, what Rondo and Brandon are saying here is this. Since we're subtracting, but we're subtracting something that is being multiplied by a negative. A negative times a negative is a positive. So this is actually going to become plus e to the t times sine of t. You see that? Understand? All right. Go back and watch the video if you're not sure and then come ask me. All right, question number 9. Number 9 is natural log of x over 2x to the 5th. Y equals the natural log of x over 2x to the 5th. Is that correct? All right, so dy dx, the derivative, is going to be derivative of the top, 1 over x, times the bottom, 2x to the 5th, which we will deal with in just a minute. Okay, you can see something's going to cancel here, right? Minus the top, the natural log of x, times the derivative of the bottom, 10x to the 4th, all over the bottom squared, 2x to the 5th, but squared. Now, to clean this up, dy dx, here's what's going to happen. This 1 over x times 2x to the 5th is the same thing as 2x to the 5th over x. See, we're multiplying the 2x to the 5th times the 1. And so it's going to become 2x to the 4th. So 2x to the 4th minus, I like to put my polynomials first. You don't have to, but I like to. So I'm going to put minus 10x to the 4th times natural log of x all over 2x to the 5th squared is 4x to the 10th power. That's it. And there's our derivative. And this could be factored and stuff, reduced, whatever. Yeah. What's that? Yep. Mm-hmm. We fill this out?
Yeah.
Thank you. Yep. All right, let's go to question, I'm just erasing 7 and 8. Let's go to question number 10. Look at this, almost 1/3 done, right? Okay, 10. We've got h of x equals cosecant over e to the x. Cosecant of x over e to the x. So h prime of x is, What's the derivative of cosecant? Negative cosecant cotangent. All right.
Oh,
Whoa, stopping, holding up. It's okay. All right. You're welcome. All right. The derivative of cosecant, the rule, the basic rule, the trig rule for the derivative of cosecant is negative cosecant cotangent.
Oh, I did negative cotangent.
That's fine. Yeah, but it's commutative. So cotangent times cosecant is the same as cosecant times cotangent, right? As long as it's negative, it includes a cosecant and it includes a cotangent. Yes. Yep. As long as it also includes a cosecant. Okay, good. Times the bottom, e to the x, minus the top, cosecant, times the derivative of the bottom, which again is just e to the x, all over the bottom squared, e to the x squared. Did you know that e to the x squared is e to the 2x power? You know, when you have this, you can multiply them. Right? So it's e to the 2x power. Okay? Can I ask you a question? In the quotient rule always includes over the bottom squared, right? Am I right? What would happen if, now you usually would not have this, it would normally be in the numerator term, but you could, watch this, you could put the negative term up here in the denominator instead. What would happen if you squared a negative term? It would be positive, yep. Yeah. I mean, it's not really that important of a point because normally we handle negatives in the numerator anyway, so it's not that big of a deal, but it's just a thought. Yes, sir?
For trigonometric terms like cosecant of
Yes.
sine, you can do cosecant squared of x. And you do that with natural log, though?
No.
So it just means
Well, let me say, I have never seen anybody communicate that way. Does that make sense? I have never seen somebody communicate the natural, I'm not saying they never have, but I have never seen somebody communicate the natural log of x squared as natural log squared of x. Maybe they do. Look it up. Do it now. Sure, look it up. Tell me. Educate me. I want to learn. Okay? But I have never seen it. Maybe I just haven't seen enough. I don't know. All right, question number 11. All right, 11 says we got g of x is equal to, well, it's not that big of a deal. We got x squared. I recommend the liberal use of parentheses on this one. X squared plus 3x minus 5 over 7x plus 2. Now, let me tell you first, if you wanted to, you could turn this into a polynomial if you want. We got do they do that? Natural log squared of x? There you go. I just learned something. Good. Look, watch this, folks. You could use polynomial long division if this is not a factor of this, which it probably isn't. You could use polynomial long division to break this down into a polynomial and then do the power rule. But because you're going to have a fraction or a rational expression at the end of that polynomial, I figure it's probably better just to use the quotient rule. So here's what I'm going to do. I'm going to put parentheses around the top and the bottom. It's going to make it a little easier to handle. And now we're going to do the derivative. G prime of x is going to be equal to, what is the derivative of the top? 2x plus 3, which you really should put in parentheses. Okay, derivative of the top times the bottom. In parentheses is 7x plus 2, right? Do you see why you have to put them in parentheses? Whoa, what's that? I'm doing the derivative of the top.
Oh, sorry.
Yeah, quotient rule, right? Derivative of the top, then times the bottom. Derivative of the top is 2x plus 3, right? Minus the top, x squared plus 3x minus 5 times what? The derivative of the bottom, which is 7. And you know what I would actually do with that? I would kind of put it in the front. I'd squeeze it in up here, yeah. That's what I would do. Minus 7 times the top. All over 7x plus 2 squared. It is appropriate to leave it like this. This is factored form of a polynomial. This is appropriate. Yes?
Can you show us how you got from right there, the top one to the bottom one?
Yes. Would you agree that 1 over x times 2x to the 5th, okay? 1 over x times 2x to the 5th. Isn't 2x to the 5th 2x to the 5th over 1? Right? So if I multiply these, wouldn't it be 2x to the 5th over x? And now what can I do with x to the 5th over x? Yeah, which is what I put here. Right? And then here, I just switched it around. I just put this in front. That's it. Are we good? And then here, 2 squared is 4. X to the 5th squared is x to the 10th. I mean, this is the same as x to the 5th times x to the 5th. And isn't that x to the 5 plus 5? Yes? This? Yeah, on my quiz you would, but if this was a multiple choice question on the AP exam, you're more likely to see this as an answer option. I'm just going on based on what I know of the AP exam, what you would be most likely to see. All right, let's do question 12. All right, 12 is acceleration is natural log over tangent. Acceleration is the natural log of t over tangent of t. Okay? Yes? Yep. Can you hand this to Chelsea behind you? Thank you. Okay. All right, so here's what we have. A prime of t, right?
Oh, I got this one.
Right? Derivative of the top, right?
Yeah.
1 over t times the bottom. Tangent of t minus the top, natural log of t, times the derivative of the bottom, secant squared of t, all over the bottom squared, which would be tangent squared of t. We can make one little tiny modification here. Yeah, let's just turn this into tangent of t over t. Okay? So let's make this tangent of t over t, and everything else looks pretty good. Tangent of t over t. Everything else looks pretty good. And yeah, you could move this, maybe you multiply through by t over t to get rid of the denominator for those people who hate fractions and fractions. Personally, how many people in here are math people? You're going to go to college and study something math related. Okay, you better just get used to fractions and fractions. They're okay. Just get used to fractions and fractions. They're all right. Yes? For number 11, what happened? You know why? This is 7x plus 2 quantity squared is an acceptable form of a polynomial. It's the factored form of a polynomial. It's acceptable. On the AP exam, I would say a good half the time. Bring it over here, Chelsea. I would say at least half the time, half of the questions that deal with higher power polynomials, they leave it in. They'll leave it in factored form. They like factored form on the AP exam. We're going to talk a lot about factored form probably in the next month or so. Okay. Okay. Let's go to 13 now. 13 is the chain rule. Well, see, listen. You hate the chain rule now, but let me tell you something. One, the chain rule is the easiest of the 3 rules. Y'all hear that? No, trust me when I say the chain rule is the easiest of the 3 rules. Okay? Second, they use the chain rule more than they use the product rule in real life problems, I guess you could say, so to speak. Well, I don't want to say it that way. On the AP exam, I see the chain rule more than I see the product rule. Okay, let's start. So we got y equals sine of x cubed. Y equals sine of x cubed. So, listen, the only hard part about the chain rule is knowing when to use it. Knowing that you are seeing a function inside of a function. So, y prime here, 3x squared, right? Derivative of the inside, 3x squared times cosine of x cubed. There we go. That's it. You're done. Now, see now? That's the chain rule. Much easier. No adding, no subtracting. Barely any canceling. It's not going to be not really any simplification for the most. Well, there is one particular time when there is a good bit of simplification. 14? No. 16. All right, 14. It's going to be real easy. 16 is awesomely easy. Okay. Hey, guys. Oh, yeah, go ahead.
Did you explain why tan t over t is bad?
This is, because the derivative of the top is 1 over t times the bottom, right? That's all we did.
Wait, what?
What just happened?
Are we good? And so now we just multiply tangent times 1 and it's tangent, right? Okay. All right, now, 14, we've got g of x is e to the 4x squared. G of x equals e to the 4x squared power. Yes, it's okay to have an exponent in an exponent. That's fine. And for me, this is old hat. This is like regular, everyday kind of stuff. All right, watch. And will be for you eventually. Now, what is the inside function? 4x squared, so the derivative is 8x. So the derivative of the inside of this there is 8x times the derivative of the outside. If this was e to the x, what would its derivative be? E to the x, right? But instead of e to the x, it's e to the 4x squared. Where there would be an x, we put the baby, right? Okay. So the derivative now is 8x e to the 4x squared. No. Derivative of the inside is 8x. And then when we do the derivative of the outside, we don't change the inside on that part. Yep. All right. Question number 15. F of x is cosine of e to the x. This is even easier. F of x is, this is really easy. Cosine of e to the x. Of course, anything that has an e to the x by itself is kind of easy, right? All right, so the derivative f prime of x. What's the inside function? And the derivative? E to the x times negative sign. That's right. Remember, the derivative of cosine is negative sign. So guess where I'm going to put the negative at? I'm going to put it at the front right here, and I'm going to make it a negative. So negative sign of e to the x. We're done. Yes. Yeah. Hugo, can you hand this to Naomi? Thanks. All right. Let's try 16. Let's try 16. Okay. We've got v of t is equal to the natural log of 2t to the fifth. 2t to the fifth. Now, listen, guys, you're going to want to see this one. Rhonda, you're going to want to see this one. Now, the derivative v prime. What's the first part of our derivative? Inside, right? 10t to the fourth power, right? 10t to the fourth times, okay. I want everybody to see this. This is very important. Go ahead.
Would it be 1 over 2t to the fifth?
Yes, it would. Yeah, see, the derivative of natural log of t is 1 over t. But where there would be a t, we put the inside, the stuff, the baby, right? Okay? So the derivative of the outside is 1 over t, but instead of 1 over t, we're going to do 1 over 2t to the fifth. Now, here's where it gets really fun. Yeah. Watch this. Ready? Are we? Oh, you do not have to put parentheses. I mean, you can if you want, you know. So now watch this. Isn't this the same thing as, can't we multiply this? Can I multiply 10t to the fourth in the numerator here? Right? So then I'll have 10t to the fourth over 2t to the fifth. Am I right? Are we okay? Right? And then now what's going to happen here? What's t to the fourth over t to the fifth? What's going to happen here? We're going to cancel how many t's? 4 of them. All 4 in the numerator get canceled, and 4 of the 5 in the denominator get canceled. Right? Yeah. Because 10 over 2 is 5. Not 5t, though. Where is the 5 in the numerator or the denominator? Right. It's 5. Well, 10. Well, no, we don't. Remember, we don't want negative exponents. So it's 5 over t. 5 over t. Okay?
That was cool.
Yep. You want to see something really neat? Yep, watch this. Yeah, watch this. Let's do the derivative of, let's say that y is equal to the natural log of 17x to the third power.
All right.
You ready?
Yeah.
Okay, so y prime is going to be, the derivative of the inside would be 30 and 20, it's 51x squared, right? Times natural log, derivative of the natural log is 1 over x, but instead of 1 over x, we're going to do 1 over 17x to the third, right? Which is now going to become 51x squared over 17x to the third, 3 over x. Do you notice a pattern yet? I mean, it's an inductive pattern, but it does work. Look, it's
It's always the
It's the exponent over the variable. Everything else is just going to cancel.
Is that always with natural log?
Yep. By the way, there's a good reason for this. There's a good reason for this. Actually, I'm not going to mess with it right now. I'll show you later. Yeah. Go ahead, Hugo.
No, I'm trying to find out the pattern.
Okay, look. So if y was equal to the natural log of 26x to the 43 power, then the derivative y prime would be 43 over x. Yeah. Now, I don't recommend that you just believe it. I recommend that you inductively try. In fact, if you want to, you can try and prove it using letters. Okay, I just wanted to show you guys that's okay. Doesn't bother me. All right. Let's do question 17. 17, h of x is tangent of the natural log of x. It doesn't matter, folks. It's just functions. No big deal. You know the rules. Just do them one piece at a time. Derivative of the inside, 1 over x times secant squared of natural log of x. And we could put that in the numerator. We could write secant squared of the natural log of x over x if we want to. Right? No big deal. Okay. Lastly, number 18, on the front. 18. Okay. We've got a of t is equal to e to the secant of t. E to the secant of t. Right? So a prime is going to be, give it to me. Yep. Let's use t though. Tangent of t times secant of t, right? All right, folks, this is the derivative of secant. So the derivative of the inside function is tangent secant times e to the secant of t, right? Done. Yep.
Yes, when you're doing derivative of secant,
Yes.
does it matter the pattern? Like how you put tan? Could I ever put like
Could you put secant tangent? Yes. Multiplication is commutative. 4 times 5 is the same as 5 times 4. Am I right?
yeah.
There you go. So it doesn't matter.